We start chapter 2.1, the concept of sets with a problem, since we've just been talking about problem solving. So in this one, we want to draw a picture, or more specifically, something we call a diagram to solve this. But let's look at the question first, and then I'll introduce the diagram to you. We have a survey of 150 freshmen, and then each of them answered questions about their major. And so we see 4 of them majored in math, 30 in English, 20 in science, 7 a double major of math and English, and none had a double or triple major with science. How many students had majors other than math, English, and science? And so looking at those numbers there seems like a puzzle problem, and it is. And without organizing ourselves, it can be difficult to solve. And so what we're going to use is a diagram like this you may have seen before. We'll talk more about this. This is called the Venn diagram. And so what I know is that I have a group of people who are English majors, group who are math, group who are science, and then you have these overlapping people who have double majors. So what I do know is that 0 people had a triple major, so I put a 0 in the middle. This middle represents there were 0 who were math, English, or math, English, or science. I also know 0 had a double major with science, so this circle represents everyone with science. So in this case here, I know I can put a 0 here because there was no one with a double major with science. We now work our way. 7 had a double major of math and English. So that's why I know there are 7 people in this group. So each of the regions represents a set or group of people. Continue. 20 were majoring in science. And so since there's 0, 0, this whole circle represents science. They are 20 people who only had science there. Let's continue. 30 were majoring in English. And so there's already 7 here who have majors in English. So this leaves me a leftover number of 23 in here. Again, 23 plus 7 is 30. That represents my third. It doesn't say major in English only. So if you are a double major, you're also an English major. So that's why we subtracted that out. 40 of them were math majors. So if there's 7 here, then that means I know this would be 33. And so then the leftover group of people are people outside of these circles. And so we know there's 150 altogether. And so what needs to happen is how many are inside the circle right now. And so to get that 150, the total, we have 23 plus 7 plus 33 plus 20. And so we're missing that missing number here, and that's how many are outside. And so out of all of these right here, that's 20, 30, 63, 73, 83, that leaves us with 67 people who are outside of those circles, and that's how many are not majoring in those. And so that's how a diagram would be used to solve it. It organizes our thinking, but we'll talk about that. That introduces us to the idea of sets. And so in mathematics, we talk about groups of things, and we come up with a language to talk about objects that have similar characteristics and belong to a group. That's called a set. And they're called elements or members of a set. And there's a specific language we use, what's called set notation, set builder notation, to represent that we're talking about a group of elements or members that have some characteristic. So you would write it out in this form here with braces. And what's the characteristic of these states here? Well, each of these states, if you're using set builder notation, is that they're border of the Pacific Ocean, right? And so it's the set of all x, such that x is a state that borders. Again, very formal language we would use. And when we're talking about sets, you got to keep in mind what we're talking about is how people count, how organize numbers. And that'll be the very first concept we learn, is this idea of numbers and what numbers are. And so, for example, looking at this task here, take your time to do that. Read the situation. And so as you read the situation, what underlying concept do children need to come to understand in order to count correctly? So you see the students have to realize that there is a set here of 3 objects, and then how you would count is that we label each of these objects, right? 1, 2, 3. And so there's this understanding that as I count, it represents an amount of objects in a set. But we'll talk more about that as we go through this chapter. So we're going to start with formal language here. We use capital letters to denote a set, like A, B, C. We have symbols. This E means an element of. An E with a line across again means not an element of. And so then we also have, it's possible that sets are empty, that no one belongs to this set of objects or elements that we're talking about. We call that an empty set or null set, and this is how we symbolize that, not with words but with symbols. A circle with a line through it, like a 0 with a line through it, or 2 braces together. And so when we talk about sets and talk about counting, which students are going to start to think about, we're going to go ahead and look at some definitions.